Hello there and welcome to the GCSE revision video. Here we're looking at the topic of indices. So let's get straight into the rules of indices. So the first rule of indices, if you have a power as a fraction, then how do you deal with a fractional power? Well, you do a two-step process. You take the denominator of that power and that would be the root of x first. So you do if b was 2, it'd be the square root of x, or if it was a 3, it'd be the cube root of x. If it was a 4 as the value for b, it'd be the fourth root of x. You find the value that when you multiply it by itself, b times will equal x. And then with that answer, you do it to the power of a. If x was a fraction itself, so it's more like a fraction to the power of a fraction, then you do the same process as before here to both the x and the y. So you do the bth root of x and y as the first step, and then you do the answer to the power of a. So it's the bth root of both x and y first, and then to the power of a. I'll show you some examples, so we're not just talking about b's and a's, we'll do it with some numbers soon. If there was a negative on your power, then you wouldn't make the answer negative, but your answer would be turned into a fraction. It would be 1 over the bth root of x to the power of a. So it's a three-step process really. The first bit would be the negative, that creates the fraction. Then you do the bth root, then you do to the power of a. And if all of this stuff on the left here happened to a fraction itself, x over y, then you would flip the fraction of x over y upside down first, like I have here, and then you do the bth root, and then you do to the power of a. Now I generally remember these rules here as a three-step process. If you are dealing with negatives in your indices, then you flip the fraction upside down. And if it isn't a fraction, just treat it as if it were a fraction, like the fraction x over 1. Then you flip the fraction upside down, and then you do to the same to the, then you follow the second and third rules. So once you flip the fraction, if it needs flipping, if there's no negative like it would be on the top two, then just skip step 1. Step 2 is your denominator. Now the denominator is the root value, so square root, cube root, etc, etc. And then the final thing you do is the power. So the numerator of your power, that would be to power that answer, whatever you've got, to the value of that power. Let's go through some examples here and I'll show you how to use this three-step process. You may want to pause the video and have a go at these if you wish to do so, but I'm going to go through them now. The first thing I'm going to do with question 1 is flip the fraction upside down. It's 5 at the moment, so I'm going to turn it into 1 over 5. And I'm going to keep the power on the 5. There's no denominator on this indice here, so I'm going to skip step 2 and go straight to the power. That's going to be 1 over 25. Excellent. Moving on to the next one. In this case, there is a negative, so I'm going to flip the fraction upside down. So it's now going to be 3 over 2. And I've dealt with the negative bit of this power now, so I can get rid of the negative on the power, so it's now just squared. There's no denominator on this one, so I'm going to skip step 2 and go straight to the power. And I'm going to do the power to the top and the power to the bottom. So it's 9 over 4. In the next one, there's no negative, so I'm going to skip step 1. I'm now going to do step 2, which is the square root of 36. And the square root is going to be 6. And there's a 1 on the numerator here, so that's to the power of 1, but anything to the power of 1 is just itself. Moving on to the next question, I'm going to first deal with the negative bit of this power. That will flip the fraction upside down, so it's 49 over 25 to the power of a half. I've dealt with the negative bit of this power, so I can drop the negative on this power. Now I need to do the denominator, that's the root, so that's going to turn it into 7 over 5. And then I'm going to do the power, and the power is just to the power of 1, so I don't really need to do anything there. So it's just 7 over 5. On the next one, I don't have any negatives, so I don't need to flip, but I do need to now cube root. So the cube root of 8 is 2, and the cube root of 27 is 3. When you cube root something, what you're thinking of is what number will multiply by itself 3 times to give, for example, 27. So what is this number here that will multiply by itself 3 times to give 27? And it's always going to be a whole number. We're not going to give you any difficult questions like 4.2365 blah 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 blah. It's always going to be a whole number. So just go through your whole numbers and test them out. 3 in this case works. 3 times 3 times 3 is 27. Then I've done the cube root of this part now. Now it needs squaring. That's the third step in this process. So it's going to be 4 over 9. Right, and moving on to the final one. The final one here is the only question on this page that has all 3 steps in it. So let's see all 3 of those steps in action. The first thing I'm going to do is I'm going to flip the fraction upside down. So it's going to be 9 over 4 because there's a negative sign on the indice. I'm not going to flip the power, just the value that's being powered. The next step is going to be to square root the top and the bottom. So that's going to be 3 over 2. So I've square rooted, that's dealt with this denominator. And now I've got the final step 3, which is to do the power. So it's 3 to the power of 3, which is 27, and 2 to the power of 3, which is 8. So there we have it. That's the final answer to this final one here. So hopefully that's made sense. Go through your 3-step process, flip it, root it, power it. Okay, and all of these sorts of rules here also work for algebra as well. And just some extra rules of algebra that you might want to know is that x to the power of a times x to the power of b, you add the powers together. That's x to the power of a plus b. Another rule is if you do x to the power of a divided by x to the power of b, you subtract the powers in that case. Or it may be represented in this form here as a fraction. This is exactly the same rule here. X to the power of a divided by x to the power of b, or x to the power of a over x to the power of b, you subtract your powers. And the last rule of algebraic indices is if you've got a power of a power, you multiply those 2 powers together. So if you're multiplying powers, you add the powers. If you're dividing powers, then you subtract the indices. And if you are doing a power of a power, then you multiply your indices together. Right then, so we'll have a go at these 4 questions here before we get stuck into the GCSE questions. So pause the video, give these a go. I'm going to now go through them now and show you how to do these questions. Okay, so for the first one, you multiply the numbers at the front as normal. So you don't add the numbers at the front here, you multiply the numbers at the front here. So that's going to give you 15. That's easy. And now we're following the step 1 rule, which is to multiply these 2 indices together. X squared times x to the 7. That's going to add the indices together, so it'll be x to the 9. Effectively, what's happened here is if I take the first one, that's x times x. And then if I take the second one here, that's going to be times, because that's the multiply in the middle, 7 x's together. So 7 x's there. So if I just count how many x's are multiplying together here, I've got 9 x's that are multiplying together. 2 from the first expression, 7 from the second expression. So it's just counting how many x's are multiplying. There's 9 x's that are being multiplied here. Let's now move on to the next question. We're going to cancel out the fractions here as normal, so that's going to be 2 over 3. And then I can subtract my powers here because that is the second rule here. So 7 take away 4 is x cubed. So it'll be x cubed on the top there. Or effectively you could think of this as 7 x's being multiplied on the top. Divide that by 4 x's being multiplied on the denominator. And if we cancel out an x from the top and the bottom, as many as we can, then we've cancelled out all 4 on the bottom, and we're left with 3 on the top. So that's another way of thinking about that rule there. Moving on to step 3, that's question 3 here, we do the power on the 3 as normal, so 3 to the power of 4 is 81, so you don't multiply the numbers here, you do the power as normal here, but then you multiply your indices. So if you've got an indice of an indice, you multiply your indices together, so that'll make it x to the 8. Effectively what's happening here is it's 3x squared times by itself 4 times. If you ever forget what the rule is here, just write it all out, because you're multiplying these indices together 4 times. So you've got 3 times 3 times 3 times 3, that's 81, and x squared times x squared times x squared times x squared, you've got 8x squareds that are being multiplied together. So 8 x's that are being multiplied together there, 4 lots of x squared, so that'll be 8x, so x to the power of 8. But there we are, this is the little shortcut here. You do 3 to the power of 4 and then multiply your indices together. And then the final one, we're going to follow it in the order of BODMAS. So I'm going to leave the power, so I'm going to leave the multiply at the front, and I'm going to do the power first. So it's going to be 5 to the power of 2 is 25, and then 3 times 2 is 6. Now I can multiply these two things together, so that's going to give me 50 x to the 7, because this is effectively x to the 1. You add your indices together when you multiply, so 50x to the 7. So I've followed the order of BODMAS here. I've done the powers first, then I've done the multiply. Right, it's now time to have a go at some GCSE past paper questions, so pause the video and give these two a go. Okay, so in the first one, we're going to flip the fraction upside down. So it's going to be 1 over 81 to the power of half. And then with the half, we square root. Power of a half is a square root, so it's 1 over 9. 1 square rooted is 1, 81 square root is 9. So there we are, that's the answer to that one there. And moving on to the second one, we're going to do the cube roots first. So the cube root of 64, that's what number times this by itself 3 times to give us 64, and if we think about it, is it 2? No, that would be 8. Is it 3? No, that's 27. Is it 4? Yes, 4 times 4 times 4 is 64. And on the bottom here is 5. 5 times 5 times 5 is 125. So we've done the cube root. Now we need to do the squaring. So it's going to be 4 squared is 16 and 5 squared is 25. So there we are, these are the two answers for these questions here. We've got a few of this type to go, so move on to the next one, pause the video and give this one a go. Okay, with this one, we're going to flip the fraction upside down, so it's now going to be 5 squared, and then it's going to be 1 over 25. Good, that one wasn't too bad. Let's move on to the next one, pause the video and give this one a go. Okay, so with this question here, first of all, go to step 1, there's no negatives, so we'll move on to step 2, do the denominator as the root. So what we now need to do is the 4th root of 16 and the 4th root of 81. Now the 4th root of 16 will be what number multiplies by itself 4 times to give you 16, and we'll go through our numbers that we know. Is it 1? No. Is it 2? Yes. The answer is 2. So it'll be 2 and the bottom will be 3. So we've done the rooting here, so now we're on to the third and final step, which is the power, which is 3. So that's going to be 2 cubed, which is 8, and 3 cubed, which is 27. So there we are, that's the final answer for this question here. Okay, let's move on to the next question then. Pause the video and give this one a go. Okay, so a power of a half represents the square root, so it's going to be the square root of 64, which is 8. And on part B, there's a bit more to it than just square rooting. So in this one here, it has a negative power, a 2 over 3 as its indice, and 8 over 125 as the value. So the first thing we do is sort out the negative power, and that will flip the fraction upside down. So that's step 1. If it's a negative power, flip the fraction. Step 2, so I'll put 2/3 there. Step 2 is to sort out the denominator, and that's going to root the top and the bottom. So that's going to be the cube root of 125, which is 5, and the cube root of 8, which is 2. So you cube root the top and the bottom. The third step is to now deal with the numerator, and that's 2, the numerator of the indice. So that's going to be 5 squared is 25. And 2 squared is 4. So what we've done here is we have cube rooted the 125 and the 8. And then the last thing we've done is we've squared those answers, so 25 over 4. And that's the final answer. Let's move on to the next one, and now we don't get the rules. Pause the video and give this one a go. Okay, so in this question here, there is no negative on the indices, so we don't need any flipping. So we're going to jump straight to the rooting. So it's going to be the cube root of 125, which is 5. And then the final thing we need to do is the numerator of the indice, which is to square it. So that's 25. So the answer here is 25. Moving on to the next one, pause the video and give this one a go. Okay, so this is the algebraic rules of indices. If you've got 2 to the 3 times 2 to the 6, that's going to become 2 to the 9. You add the indices together. Effectively, you could think of it as we've got 3 2's being multiplied together here and 6 2's being multiplied together here. So we've got 9 2's that are being multiplied together in total. In this one here, when you've got a divide, you subtract your indices. So it's 3 to the power of 5 here. And in the last one, let's simplify the denominator of this one. So it's 5 to the n over 5 to the 10. That equals 5 to the 3. So if we're subtracting in the indice here and the answer is 3, then n must equal 13, because 13 minus 10 will equal 3. Let's move on to the next one. Pause the video and give this one a go. Okay, let's simplify that denominator first. So I'll leave the 5 to the 12 on the top. And on the denominator, it's going to be 5 squared times 5. That'll be 5 cubed, because I've got 3 5's that are being multiplied on the denominator there. You could effectively think of the 5 as 5 to the 1 and add the indices as well. And then you subtract your indices, so it's going to be 12 take away 3, that'll be 5 to the 9. So the answer here is 5 to the 9. Moving on to the next one, pause the video and give this one a go. Okay, so for this question here, we're going to be using this rule from the rules of indices. So it's going to be, when you do a power of a power, you multiply your powers together. But with the 4, to get the ball rolling, you just do the power as normal. So because the 4 is just a number at the front, you do 4 cubed. And 4 cubed is 64. And then h to the power of 2/3 to the power of 3, you're going to be multiplying your powers together. So it's going to be 2/3 times 3. Treat this as 3 over 1, and you can multiply top by top, bottom by bottom, and then simplify, so it will just simplify to 2. Or you could think of it as 2/3 times 3. Well, the thirds and the 3 will cancel out, so you're just left with 2. So your answer here is h squared. And that's your final answer. In fact, it doesn't really need brackets. 64 h squared is your answer. Okay, let's move on to the next one. Pause the video and give this one a go. Right, this one's a little bit more tricky then. So it's going to be a times the square root of a, and we all know that the square root of a is a to the half. That's what it would be as an indice. Over, now it's going to be a squared, and root will be 3. So if the root is the number 3, and the power is squared, it's going to be a to the power of 2/3, because the third is the rooting value, and 2 is the powering value. Let's tidy up the top now. It's going to be a to the power of 3 over 2, because you add your indices together. This is a to the 1 at the front here, and add your indices to a to the 3 over 2. And on the denominator, it's going to be a to the power of 2/3. Now that we're dividing, we need to subtract our indices. So it's 3 over 2 minus 2/3. Let's create a common denominator there of 9 over 6 minus 4 over 6. So that's going to be 5 over 6 as the power of a. So it's going to be a to the power of 5 over 6. So therefore, k equals 5 over 6. So there we are, using a lot of the rules of indices there to simplify this question here. Very difficult question, but very well done if you got it. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so in these two questions here, we're using again this bottom rule of indices here, whereby if we're doing a power of a power, we multiply the powers together. But with the first one, the 3 to the power of 4, you do that as normal, because it's just a normal 3 to the power of 4, so that'd be 81. A squared to the 4, you multiply your indices there, that'd be a to the 8. And then it'd be b to the power of 4. You could think of this as b to the 1 to the 4. So that's just going to be 1 times 4 is 4, or b to the 4. There we are, that's the answer for that one. And moving on to the second one, we're going to do the 9 to the power of a half as normal, because 9 is a normal number. 9 to the power of a half is 3. You square root as you do a power of a half. And then it would be c to the power of 8 to the power of a half. So you need to do 8 times a half, which will be 4. So it would be 3c to the 4. And there we are, that's the answer for these two questions here. Let's move on to the next one. Pause the video and give this one a go. Okay, so we're fully immersed in the algebraic indices questions now, it looks like. So it's going to be 4 times 6. You do the numbers, the normal numbers multiplying as normal. So that would be 24. P cubed times p squared. Well, in here you've got 5 p's that are multiplying together in total, or you could think of it as adding your indices. And then q to the power of 5 times q, that's effectively q to the power of 1, and add your indices together, that would be q to the power of 6. And with this question here, you do the power as normal for the 5 as normal at the front, so that would be 125. Then when you're doing a power of a power, you multiply your powers together, so it would be x to the 6 and y to the 12. So there we are, that's the answer for that one. Moving on to the next one, pause the video and give this one a go. Okay, your normal numbers at the front get multiplied as normal, that would be 10. And then you add your indices, so it's e squared times e to the 3, that would be e to the 5. And then f times f is f squared. So there we are, that's the answer for this one here. Moving on to the next one, pause the video and give this one a go. Okay, so when you're dividing indices, you subtract the powers, so it's going to be g to the power of 6 on this one. And with this second one here, it's going to be multiply the normal numbers as normal, so that's going to be 18. And then you add your indices, so it'd be e squared times e to the 1 effectively, so that's going to be e to the 3. And then we've got m to the 7 times m to the 4, that's going to be add your indices, m to the power of 11. So there we are, that's the answer for the second one. Moving on to the next question, pause the video and have a go at this one. Okay, in this question we need to do the normal number to the power as normal, so that's going to be 64 to the power of a half, that's going to be 8. And then we multiply our indices, so it's going to be a half to the power of 6, 6 times a half, that's 3. And 2 times a half, that's 1, so it's just c to the power of 1, which we'll just write as c. So you multiply your indices if you've got a power of a power, but with the normal number at the front, you do the power as normal. Moving on to the next question, pause the video and have a go at this one. In this question here, it's 5 times 7 is 35, times the normal numbers as normal. And then you add your indices, so it's going to be u squared times u to the 1, that's going to be u to the 3. And then it's going to be w to the 4 times w to the 3, you add your indices, so it's w to the 7. Moving on to the next one, pause the video and have a go at this one. Okay, so you do 4 to the power of 2 as normal, because 4 is a normal number at the front, so that's 16. And then you multiply your indices together, so it'd be e to the 6. There we are, let's have a go at the next one, pause the video and have a go at this one. Right, so what I'm going to do here is I'm going to treat this as a simplifying fraction question rather than an indices question. Let me show you what I mean by that. I'm going to think of 15, well, as 15, then it's going to be times e squared, that would be e times e, and then times f. Over, then it's going to be 25 times e times f times f times f. And I'm going to have a look at what I can simplify on the top and the bottom. Now I can definitely simplify the normal numbers at the front, take out a factor of 5, and I've got 3 over 5. I could cancel out 1e from the top and the bottom, and I can cancel out 1f from the top and the bottom. So that will leave me with 3 times e over 5 times f squared. Okay, we could possibly see how to do this just from the initial question. Simplify the 5 out of the 15 and the 25, cancel out one of the e's from the top and the bottom, and cancel out one of the f's from the top and the bottom. So that way I've fully simplified my fraction straight from the question. So there we are, that's the final answer for this one. Moving on to the next one, pause the video and have a go at this one. Do this one in the same method I used for the last one. Okay, so with this question here, I can cancel out a 4 from the top and the bottom. That will leave me with 7 and 1 on the denominator. Don't really need that 1 though, do we? Because it's always just 1 times something. I'm going to cancel out one of the x's from the top and the bottom, so that will leave me with 4 x's on the top. And I'm going to cancel out 2 of the y's from the top and the bottom, so that will leave me with just 1 y on my numerator. So I've cancelled out everything from the denominator, so that's just going to effectively be 1 on the bottom. So it's going to be 7x to the 4, y to the power of 1 over 1, and I can always simplify anything where it's over 1 to just 7x to the 4, y. So there we are, that's our final answer for this question here, fully simplified. Okay, let's move on to the next one. Pause the video and have a go at this question. Okay, so what can I simplify here? I can simplify a factor of 6 from the top and the bottom of the number, so that will be 6 and 5. I can cancel out 3 of the x's from the top and the bottom, so I'll take away all of them, and I'll have 2 of these left. And I'll cancel out 1 of the m's from the top and the bottom, so I'll have 3 left on the top. So that leaves me with 6m cubed over 5k squared. And there we are, that's the final answer for this question. Moving on to the next one, pause the video and have a go at this question here. Okay, so with the first one, it's doing a power of a power, so you multiply your powers together, p to the power of 10. And with the second one here, we can do the division and do subtracting of indices. So 12 divided by 6, you do the division as normal for the normal numbers, that would be 2. And it's x to the 7 divided by x to the 3, you subtract your indices there, x to the 4. And then y to the 3 divided by y, that would be y to the 1, subtract your indices, y squared. So there we are, that's the final answer for part B. Let's move on to the next one, pause the video and have a go at this question. Okay, the first one's very easy, isn't it? You just add your indices together, m to the 7. And with the second one, you do the power as normal for the normal number at the front, so that's going to be 125. N to the power of 1 to the power of 3, or n to the power of 3 is just n cubed. And then you multiply your powers in the p one, so it's 3 times 3, that's 9. So there we are, that's the answer for part B here. Okay, so let's move on to the next one. Pause the video and give this one a go. Okay, so we're looking to simplify this fraction here. What we could probably do is cancel out the factor of 4 from this value here, so that would be 8, and 4 disappears, so it would just be a 1 really. We could cancel out 3 q's from the top and the bottom, so I'll be left with 6 on the top, and the 3 will cancel on the bottom. And with this one here, I'll cancel out 1 of the r's from the top and the bottom, so I'll left with 3 on the top. So it's going to be 8 q6 r3 over 1, but we don't generally write a fraction over 1, we'll just leave it like that. Let's move on to the next one, pause the video and give this one a go. Okay, so you do the power on the 8 as normal because it's a normal number at the front. So 8 to the power of a third, that's the cube root of 8, which is 2. And then you multiply your powers together. So it would be 9 times a third is 3, and 6 times a third is 2. So there we are, that's the answer to that one. Moving on to the next one, pause the video and have a go at this one. Okay, a difficult question this one. What we've got to remember for this one is that the square root of x can be represented as a power of a half. And once we've got that breakthrough, it's now just a half times 8, which is 4. So there we are, it's x to the 4. Okay, moving on to the next one. Pause the video and have a go at this one. Okay, so we're going to do 27 to the power of 2 over 3. It's a normal number at the front, so we'll do the power as normal. So you cube root to 27, that will be 3, and then you take that answer and square it, so it's going to be 9. And then you multiply your indices, so it's going to be 6 times 2 thirds, so that's going to be 4. So there we are, that's the answer to that one. Okay, let's move on to the next one. Pause the video and have a go at this one. Right then, this one's quite a difficult one here, so I'm going to break this down into this 3 different stages. So the first stage is going to be dealing with the negative part of this indices. So that means the fraction is going to flip upside down. So it's 27f cubed over 125 e to the 12. Then it's going to be 2 thirds. Now the next thing I need to do is I need to do the denominator part of this fraction. That's going to cube root anything inside the brackets, or if it's got an algebra piece on it, you multiply that indice bit together. So in fact, let's just do the whole thing. Yeah, let's do the whole thing. So it's cube root and then square for the numbers and then multiply for the indices. So let's take it in turns. 27. First of all, we're going to do the cube root of 27, that's 3, and then we take that answer and square it, so that's going to be 9. For the next part, you multiply your indices together, so 3 times 2 thirds, that's f squared, over 125, that's a normal number, so we're going to cube root it first, that's 5, and then we're going to square it, so that's 25. And with the 12, you're going to multiply the indices together there, so that's going to make it e to the power of 8. And there we are, that's the final answer for this question here. Difficult question, that one. Let's move on to the next one. Pause the video and have a go at this question. Okay, so let's do the power on the 2 as normal, because 2 is a normal number, so that's going to be 16. With this indice here, we're going to multiply the indices together, so 4 times 3 halves. Treat that as 4 over 1 and multiply the fractions together. 12 over 2 is 6, so it's going to be x to the power of 6. And then y to the power of 4, that's just y to the power of 4. And there we are, that's the final answer for this one. Let's move on to the next one. Pause the video and have a go at this question. Okay, so with the 8, we're going to do the power of third as normal. 8 to the power of a third is 2. Then we multiply the indices together on the top and the bottom. So it's going to be e to the 2 over f to the 4. And there we are, that's the final answer for this question here. Moving on to the next one, pause the video and have a go at this question. Okay, so we're going to do the 8 to the power of a third as normal. 8 to the power of a third is 2. And then we're going to multiply the indices together. So 6 times a third is 2, so it's a squared, and 3 times a third is 1, so that's just going to be b. 2a squared b is your final answer. Moving on to the next question, pause the video and have a go at this one. Okay, so again, difficult question this one. We're first going to deal with the negative part of this this indice here. That will flip it upside down, so t to the power 15 over 27a to the 12. Now the next step is to do that power of 2/3. So with the indices, they're going to multiply together, and 15 times 2/3, treat it as 15 over 1 and multiply top by top, bottom by bottom. That's going to be 10 when it gets simplified, so t to the 10 over. 27 is a normal number, so you do the power as normal, so that's going to be cube root of it first, that's 3, and then times it by, so that's 3, and then square it, so that's going to be 9. And then you multiply these indices together again, so it would be 12 times 2/3, treat it as 12 over 1, do top times top, bottom times bottom, so that's going to be 8. So it's going to be a to the 8. So there we are, that's the final answer for this question. Moving on to the next one, pause the video and have a go at this question. Okay, so for this one here, we're going to do the power on the 16 as normal. So you do the 4th root of 16, which is 2, and then 2 cubed, so that'll be 8. And then you multiply your indices together, that's going to be y to the power of 6. So 3/4 times 8 is 6. Okay, let's move on to the next one. Pause the video and have a go at this question. Okay, so let's do each of these individually and then we'll multiply together at the end. The power of a half is a square root, so that means the square root of 144 is 12. For this question here, it's going to be a negative power, so that would be 1 over, and then it's going to be the cube root of 64, which would be 4. So 12 times the cube, so 12 times 1 over 4 is 3. So the answer here is 3. Moving on to the next one, pause the video and have a go at this one. Good, hopefully this one wasn't too bad. Anything to the power of 0 is just 1. So there we are, the answer is just 1. Doesn't matter whether it's algebra, numbers, 5 to the power of 0, that's 1. A to the power of 0, that's 1. Anything to the power of 0 is just 1. Moving on to the next question, pause the video and have a go at this one. Right, I get a sense here that the difficulty on these questions has just ramped up a notch. Okay, we want 2 to the p times 8 to the q to equal 2 to the power of n, and we want to write n in terms of p and q. Difficult question, this one. Right. What I'm going to do here is first of all change both of these bases into a 2. So 2 stays the same, but 8 can be written as 2 cubed. Equals 2 to the n. So you can see what I've done here. I've changed my 8 into a 2 cubed, so now that all the bases are 2, and it's much more easily comparable when they're all a base of 2. I'm now going to sort out this indice here. When you simplify this, it's going to be to the power of a power. You multiply your powers together there. 2 to the power of 3q equals 2 to the power of n. And then to simplify the left-hand side, you add your indices together. So it's going to be 2 to the power of p plus 3q equals 2 to the power of n. So now that we've got them as one combined indice on both sides, we can directly compare the indices. So it's n equals p plus 3q. Very difficult question, that one. We're now going to get a bunch of these coming up. So hopefully you've understood this one here. Turn the 8 into a 2 cubed, and then add your indices together, and then you get an answer of n equals p plus 3q. Okay, let's move on to the next question. Pause the video and have a go at this one. Okay, so for the first one here, it says 1 over 5 to the power of 3 equals 5 to the power of p. Well, the value of p here must be a negative number, because that's what created the fraction, and it must be a 3, because that's the power on the 5 on the bottom, so p must be minus 3. In this one here, it's 5 to the power of something equals 1. Well, we just saw a couple of questions ago that when q equals 0, anything to the power of 0 is 1. And then with this one here, the root on the 5 here is a 2, so that must mean the denominator of the power is a 2, and then 5 is being cubed, so it would be a power on, so the indice numerator will be 3, so it would be 3 over 2 for that third one there. Okay, let's move on to the next one. Pause the video and have a go at this question. Okay, so in this question here, the 5 is going to be cubed as normal, so that's 125. Then we multiply the indices together, so 4/3 times 3, that's just h to the 4, because effectively this 4/3 here is a third of 3, that's just those two bits cancel out, so it's just 4. And then you multiply the 2 by the 3 on the g indice, so that would be g to the 6. So there we are, that's the answer to this one. Let's move on to the next one. Pause the video and have a go at this question. Okay, this is more like a simplifying fractions question. I've got a factor of 4 and a factor of, if I write this out, you'll probably more likely be able to see it. Y plus 3, y plus 3, y plus 3. So with y plus 3 bracket is being cubed, multiplied by itself 3 times. On the denominator, it's going to be y plus 3 times y plus 3. So I've got 4 factors on the top, a 4, a y plus 3, a y plus 3, and a y plus 3. And on the bottom I've got 2 factors, y plus 3 and y plus 3. So I can cancel out one of the y plus 3's on the top and bottom, and another y plus 3 on the top and the bottom. So that leaves me with 4y plus 3. It will be effectively a 1 on the denominator, but we don't generally write our fractions with a 1 on the denominator. It's just 4 brackets y plus 3. You could effectively think of this as cancelling out 2 of the y plus 3's on the top and the bottom. So it's just 4 brackets y plus 3 to the power of 1 on this one. Okay, let's move on to the next one. Pause the video and have a go at this question. Okay, so in this one we're multiplying our indices together. They're both negative, so they'll make a positive. So it'll be x to the power of yz. I've multiplied my indices together there. That's the answer to this one. Okay, moving on to the next one. Pause the video and have a go at this one. Okay, so Patrick has to work out the exact value of 64 to the power of a quarter. Patrick says that a quarter of 64 is 16, so the answer must be 16. Explain what is wrong with what Patrick says. Well, Patrick is doing a quarter of 64 rather than doing a root of 64. Patrick should do the fourth root of 16. This is what the fourth root looks like. It's a little 4 on the tip of a square root. So it's the fourth root of 16, which equals 2. So that's what Patrick should do. Moving on to the next one. Pause the video and have a go at this question. Okay, so let's have a go at this one then. So let's do the normal numbers multiplied together as normal. So it's going to be 8. And then it's going to be add the powers together. So it's going to be a to the 5 and b to the 9. Moving on to this second part here, let's rewrite the bottom of this square root as an indices. So it's going to be c squared, because that's the power on it, and then the root will be the denominator of that power, 2 over 4. Now first of all I could simplify that fraction to a half, and the way I can write that, write the 1 over c to the half as an indice will be c to the minus a half. Remember, minus powers create the fraction, so therefore we can say here that k equals minus a half. And there we are, that's the answer to this question. Let's move on to the next one. Pause the video and have a go at this question. Okay, let's go through each 3 of the different parts. So for A, we create a fraction, so it means it's going to be a minus power. And then it's 9, so that must be 3 squared, so that makes the power minus 2. On part B, 9 is 3 squared, and this is being multiplied by the square root of 3, which is 3 to the half. So that means we're going to add the powers together, so that makes it 5 over 2. And for the last one, the square root is formed by a power of a half, and the 1 over means it's minus a half. So a plus b plus c is going to equal 0. So there we are, that's the answer to part B. Moving on to the next one. Pause the video and have a go at this question. Okay, so we're going to use the rule here of adding the indices to create the 9. So 3 add x equals 9. So therefore x must clearly equal 6. Good, let's move on to the next one. Pause the video and have a go at this question. Okay, so in this question we need to identify n. N is going to be a negative power because that will create the fraction 1 over t cubed, and the cubed will be because n is a power of minus 3. So the 3 will stay on the t and the minus will create the fraction. Moving on to part B. This question is a simplifying fractions question, so I'll simplify the 3 out of the normal numbers at the front. X's can cancel out top and bottom, and then 2 of the y's can cancel out top and bottom, so I've got 3 left, so this answer here is 2y cubed. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, let's rewrite the bottom as indices, so it's going to be p to the 1 times p to the 2/3, because 2 is on the power and 3 is the root value, so it's going to be 2/3. Let's multiply these two together, so it's going to be p to the 5/3, and then the 1 over is going to be created by a negative on the power, so it's minus 5/3, so therefore m is equal to minus 5/3. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so in this question here, what I'm going to do is I'm going to start by simplifying the left-hand side. In this question here, I'm going to cancel out 2 of the y's from the top and the bottom. So cancel out 2 from here and 2 from here. So it's going to be y squared times y to the n. I don't need to cancel out any on the y to the n because these are all being multiplied together and these are all being multiplied together, so I just need to cancel out 2 from all of the top and all of the bottom. So it's therefore going to be y to the power of n plus 2. You add the indices together when you're multiplying algebra, so it's going to be n plus 2 equals minus 3 if we compare this and this. So therefore n is going to equal minus 5. Okay, there we are. That's the answer to this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this one I'm going to do this one slightly differently. So I'm going to add my algebra together on the top, add my indices together on the top, and then I'm going to subtract 6 from the numerator, so it's going to be 5 to the n plus 3 minus 6, because you subtract indices when you're dividing, and this is going to equal 5 to the 4. So simplify your indices, so it's going to be n minus 3 equals 4, because the indice here should equal the indice here, and I've simplified the algebra on the left, so n here is equal to 7. And there we are, that's the answer to this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question I'm going to treat this as 8 times 10 to the 6 to the power of a third. And I'm going to be doing a third times, a third to the power, 8 to the power of a third, so power your normal number is normal, so that's going to be 2. And then I'm going to multiply my indices together, so that's going to make it 10 to the 2, so in total that's going to make it 200. So there we are, that's the answer for this question here. Let's move on to the next one. Pause the video and give this one a go. Okay, so with this one here, I'm just going to leave the fifth root alone for now. I'm going to change the number that's inside the bracket here. I'm going to borrow one of these 10s and put it on the 3.2 to make it 32. So I've used up one of those 10s and it's now 10 to the 10. Now I'm going to rewrite this as 32 times 10 to the 10 to the power of 1/5. So I'm going to power the normal number at the start as normal, so that's going to make it 2. And I'm going to multiply my indices together to make it 10 to the 2, which makes it 200. And there we are, that's the answer for this question here. Okay, let's move on to the next one. Pause the video and give this one a go. Right, so in this question here, I need to make m to the power of -1/3. So I'm going to take this value of m here and multiply it, and do it to the power of 1/3. Just a -1/3, actually, -1/3. So I'm going to do the power as normal with the 8 at the front, and then multiply my indices together. So it's going to be 1/2 at the front, so that's 0.5 times 10 to the -3n. You multiply your indices together, and then you do the power as normal at the front. 1/2 is 0.5 times 10 to the -3n. So this number is not in standard form at the moment because the 0.5 at the front. So I need to make this 10 times bigger, and therefore I need to make this 10 times smaller. So it's -3n to the -1. And there we are, that's the final answer for this question here. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so I need to now make this to the power of 5/4. So it's going to be 16 times 10 to the 8k to the power of 5/4. So I'm going to do the power as normal to the number at the front. So root it by 4, that'll get it down to 2, and then 2 to the power of 5 is 32. And then you multiply your indices together, so that's going to make it 10k. But I need to write my answer in standard form, so I need to change the 32 into 3.2, and so I've reduced that and made it smaller. So now I need to make the power bigger. So it's going to be 10 to the power of 10k plus 1. I've made it one more power of k, one more power of 10 bigger, because I've made this a power of 10 smaller. So there we are, that's the answer for this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so on part A, it's 9 times 10 to the 2m to the power of 1/2, because that's what it is, it's square rooting here. So do the power of 1/2 on the 9 as normal at the front, because it's a normal number, and then multiply your indices together, so that's going to make it 10 to the m. Lovely, so there we are, that's the answer to part A. And moving on to part B, it's 9 times 10 to the 2n to the power of 3/2, this one. So do the power as normal, so that's going to make it 27 times 10 to the 3n. You multiply your indices together. Now I need to write this as standard form, so it's going to be 2.7. So I've made this smaller here. So now I need to make the power bigger, so it's 3n plus 1. So there we are, that's the answer to this question here. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question I'm going to rewrite the right hand side as a power of 3. So the minus on it, so that the fraction on it, the 1/81, will make it a minus power. So it's going to be 3 to the minus. And then how will I get 81? Well, 3 squared is 9, 3 cubed is 27, 3 to the power 4 is 81, so it's 3 to the minus 4. And that's what 3 to the power of 2x is equal to. So the powers must be equal to each other now. 2x equals -4, so x equals -2. So there we are, that's our equation solved, x equals -2. Moving on to the next one, pause the video and give this one a go. Okay, so having a go at this one, on the left-hand side, when we solve this equation here, it's going to be 7 to the power of 2y, multiplying those indices together, equals 7 to the 10. And then now the powers are equal to each other, so y must equal 5. So there we are, that's the answer to part A. And now we've got 100 to the power of A times 1000 to the power of B, can be written in the form 10 to the W, show that W equals 2A plus 3B. So here we have 100A times 1000B equals 10 to the W. So 100 could be 100 squared to the power of A. 1000 could be 10 to the power of 3 to the power of B equals 10 to the W. Now expand your brackets by multiplying your indices together. 10 to the 2A, 2A times 10 to the 3B equals 10 to the W. Now add your indices together. 10 to the power of 2A plus 3B equals 10 to the W. So therefore your indices will be equal 2A plus 3B equals W. So with this question here, it's a show that question. So I've made extra sort of steps in here to really emphasize that I know how this is proved, and I've made it really clear what we're doing in each step. So we're rewriting the powers here of 100 and 1000. Now we're expanding the brackets. Now we're applying the addition law of indices, and now we're rewriting it as an equation. So there we are. I've made it really clear that I understand what's going on in this question, because it's to show that no marks are given for the answer, all the marks are given for the working out. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, this question's a bit harder than previous. I think what the key to this question here, though, is that it's all to the power of 2. So if I rewrite out that 8 and the 16 to the power of 2, I might be able to make a breakthrough. So 16 is 2 to the power of 4. And we then have 2 to the power of x, and then 8 is 2 cubed. Okay, let's now expand the brackets. It's going to be 2 to the 4/5 times 2 to the x equals 2 to the 9/4, multiplying our indices together to expand the brackets. Now let's move the 4/5 onto the other side, so it's going to be 2 to the 9/4 divided by 2 to the 4/5. So because it's being multiplied onto the 2 to the x here, it needs to be divided onto the other side. Divide by 2 to the 4/5. So therefore I subtract my indices. So it's going to be x equals 9/4 minus 4/5. Create a common denominator of 20 there. So 20 on this one. That would be 45 on the top of this one. And then minus 20 on the bottom here. Multiplied by 4, so that'd be 16. 45 minus 16. Take away the 6 is 39, so it'd be 29/20. So there we are, that's the answer to this question here. 29/20 is the value of x. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so I think the key to this question here is that it's all based on a power of 3. So I'll rewrite the equation as powers of 3. So it's going to be 3 squared to the power of -1/2 equals 3 to the cubed to the power of 1/4 divided by 3 to the x plus 1. So let's expand our brackets here. So it's going to be 3 to the -1 and 3 to the 3/4 divided by 3 to the x plus 1. Let's now group together the indices on the right hand side. So it's going to be 3/4 minus, because you minus indices when you divide, minus x plus 1. Okay, so now that I've got that, powers of 3 on both sides, I can now equate the left and the right hand side together. So the power on the left is -1, and the power on the right is 3/4 minus x, and then -1. because I need to subtract both the x and the minus 1. So now I need to solve this, so I've got a minus 1 on both sides, and I can move the x onto the other side, so x equals 3/4. So there we are, that's the answer for this question here. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so for this question here, I think the route into this question here is to do it all to the power of 2. So 4. 4 is 2 to the 2 to the power of n times 2 cubed all to the power of n plus 1 equals 2 to the power of 4. Let's now expand the brackets on the left hand side. 2 to the 2n, multiplying your indices to expand the brackets, times 2 to the 3n plus 3 equals 2 to the power of 4. Let's now multiply our indices together so we add them. So it will be 5n plus 3 equals 2 to the 4. So now we've got an equation whereby 5n plus 3 equals 4. I'm saying the powers equal to each other here. So therefore 5n equals 1. So therefore n equals 1/5. So there we are, that's the answer to this question. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so in this question, let's first of all rewrite the 8s as 2. So it would be 2 cubed squared times 2 cubed to the power of 3 all over 2 cubed to the power of 4. Let's now simplify all of our indices here. It's going to be 2 to the 6 times 2 to the 9 divided by 2 to the 12. So let's add the indices on the top, 2 to the 15 over 2 to the 12, and subtract our indices now because they are dividing, so it will be 2 to the power of 3, so therefore n equals 3. And there we are, that's the answer for this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so we're writing n in terms of x and y. So first of all, on the left hand side, I'm going to expand the brackets. It's going to be n over 2. On the right hand side, it's going to be 2 to the x, and then I'm going to rewrite the 8 as 2 cubed to the power of y. So therefore 2 to the power of n over 2 equals 2x over 2 to the 3y. So this is on the next line. On the next line is going to be 2 to the n over 2 equals, now I'm going to subtract the indices because they're being divided here, 2 to the power of x minus 3y. Now I've got the same indice on the bottom here, so it's going to be equal to the left and the right on the indices. So it's going to be n over 2 equals x minus 3y. And then multiply everything by 2 to get rid of the divide by 2 on the left. That's going to make it 2x minus 6y. So there we are, that's the answer for this question here. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so write x in terms of n. So first of all, I'm going to simplify it on the left-hand side by adding the indices together. So that's going to be 2 to the power of, well, a half to add n over 3. So common denominator of 6. So it's going to be 2n plus 3 over 6 equals 8 I'm going to rewrite as 2 cubed, and 4 I'm going to rewrite as 2 squared. So on the left hand side we'll keep that as it is, and on the right hand side it's now going to be 2 to the 3x over 2 to the 2n. Okay, I want to make x in terms of n, so I'm going to now multiply this thing here onto the other side. It's being divided at the moment Oh no, in fact, no, I won't do that. You could do that method, but no, I'm just going to subtract the indices now. So it's going to be 2 to the power of 3n, 2n plus 3 over 6. And now I'm going to subtract the indices, so it's going to be 2 to the power of 3x minus 2n. So now that we have a common base, we can now equate the indices. So therefore, 2n plus 3 over 6 equals 3x minus 2n. So I'm going to add 2n to both sides to move it on the other side. So I get x in terms of n. So it's going to be 2n over 6 plus 3. I'll just write that as a common one. 2n plus 3 over 6, add 2n equals 3x. Now to tidy this up and make it really algebraically tidy, I need to add these two fractions together now. So I'm going to rewrite 2n as 12 over 6, and I can add them together, so it's going to be 14n plus 3 over 6 equals 3x. And then I'm going to divide by 3, so that will make it 18 on the bottom there. So 14n plus 3 over 18 equals x. And there we are, that's the final answer for this question here. So lots of maneuvers there. We had a question about adding fractions, we had an indices question, and a rearranging formulae question. Lovely, that's a great question with 3 topics nicely packed into one question there. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, the first thing I'm going to do here is I'm going to divide by 3 on both sides. So it's going to be 4 to the power of 2k plus 8 equals 8, because 24 divided by 3 is 8. I'm now going to rewrite 4 and 8 as having a base of 2. So it's 2 squared, 2k plus 8 equals 2 cubed. Let's multiply out the brackets here by multiplying the indices. 4k plus 16 equals 2 cubed, and now let's set the indices equal to each other, so it's 4k plus 16 equals 3. So now I need to rearrange this, so 4k equals minus 13, so therefore k equals minus 13 over 4. And there we are, that's the answer to this question here. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, this is a very tough question. I really do hope you've given this a real good go. So, first of all, I'm going to cancel down the 6's, so it's a 2 at the front there, and the 6 gets cancelled there. Now I'm going to rewrite these fractions, changing the 8 and the 4 into powers of 2. So it's going to be 2 times brackets. So how am I going to do this here? Maybe I write it as 2 cubed and then I move the square root, because that would be representing a power of a half, as an over 2 to the power of 2y plus 2 over 2 squared, so it's going to be 2 squared over 2y plus 1. Okay, let's start simplifying here. So it's going to be 2 times, multiply the indices together, so it's going to be 2 to the power of 3y plus 3 over 2 to the power of 4y plus 2. So I'm expanding the brackets here by multiplying the indices together. Let's now move up over here. So I'm going to now add the indices together because we're multiplying the algebra here. So it's going to be 2 to the power of 3y plus 4 over 2 to the power of 4y plus 2. And now the final thing to do will be to subtract your indices here, because you're dividing them, so it would be 2 to the minus y plus 2. So there we are. So that's equal to 2 to the p, so therefore p is equal to minus y plus 2. So there we are. So I've rewritten this big complicated piece of algebra here in the form 2 to the p. So it's 2 to the minus y plus 2. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so let's simplify the left-hand side then first. So on the first indice, it's going to be 5 to the power of n squared minus 6 times 5, and then on the second fraction, it's going to be 5 to the power of n squared minus 5n minus 3, because when you're dividing, you subtract the indices. And on the right-hand side, this is going to be equal 5 cubed. So let's now add our indices together. So it's going to be 2n squared minus 5n minus 9 equals 5 to the power of 3. So therefore, the indices are equal. 2n squared minus 5n minus 9 equals 3. So what we need to now do is, this is now a quadratic equation where I need to make one side equal 0. So I'm going to subtract 3 from both sides. 2n squared minus 5n minus 12 will equal 0 now. So from this step to this step I've subtracted 3. Let's now factorize. So it's going to be 2n and n. So it's 12 and 2, so that would be 3 and 4. So one of them is going to multiply by 3, so I'll make it minus 4 here and plus 3 here, because that'll make it minus 8n, and plus 3, that'll make it minus 5 and n in total. So that will make this bracket here equal 0, so 2n plus 3 equals 0. So n is going to equal, if you move the 3 on the other side, you subtract 3 and then divide by 2, minus 3 over 2. And for this bracket here, n needs to equal 4 to make this bracket equal 0. So n equals 4 and n equals minus 3 over 2. So just this isn't part of the video, this is a solving quadratic equations part, but to make this fraction equal 0, we need these two multipliers to multiply to make 0. So either one of these brackets should be 0, because that's a rule to do with multiplying to make 0. One of these things must equal 0. So either the 2n plus 3 equals 0, in which case n is minus 3 over 2, or this bracket equals 0, in which case n is equal to 4. So there we are. These are the two answers for this equation here. Oh, sorry, so where n is greater than 0, so it's not this one here, it's just n is equal to 4, because where n is greater than 0. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, let's multiply our indices together on the bottom. So it's going to be 2 to the power of n plus 6 equals 1. So now we subtract the indices, so it's going to be 2n squared minus n and minus the 6 equals, now 1 is equal to 2 to the power of 0. So that's the little trick that you have to use here. So therefore now the indices are equal to each other. N squared minus n minus 6 equals 0. So now we have this as our quadratic equation that needs solving. So we'll need to factorize it. N minus 3 n plus 2 equals 0. So what do we need the values of n to be to make these two brackets equal 0? Well, n is equal to 3 or n is equal to minus 2. So there we are. These are the answers for this question here. Let's move on to the next one. Pause the video and give this one a go. Okay, so let's write out the number n then. So n is equal to 10 to the 3 times 10 to the 3 to the power of 10 to the 3. Ooh, eek. Okay, so this question looks very difficult here. So let's now rewrite this as 10 to the n, where n is an integer. So it's going to be, so for the first bit we'll just leave 10 to the 3 alone. And then it's going to be 10 to the 3 times this, so it's going to be 3 lots of 10 to the 3, so that's going to make it 10 to the power of 3 times 10 to the 3. 10 to the 3 is equal to 1,000, so that's going to be 10 to the 3 times 10 to the 10,000, sorry, not 10,000, 10 to the power of 3 is 1,000, times 3 is 3,000, and then we add our indices together, so therefore it's going to be n equals 10 to the power of 3003. So therefore n is equal to 3003. So what were the steps that we had to go through here? Well, we multiplied our indices together, like we did here, and then we rewrote it as an actual number. 10 to the 3 is 1,000, so it's going to be 3,000. And then we added our indices together from this step to this step by adding them, so it's 3003. So there we are, that's the answer to this question here. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so in this question here, given that y is equal to this, find the value of y and the value of k. So if y, I'm going to rewrite out y is equal to 4ax squared equals 4a to the k times z to the w. Now z is equal to this thing here, so I'm going to put in brackets a squared x cubed to the power of w. So I can cancel out the 4 on both sides. So I've now got ax squared equals a to the k times, and now I'm going to expand the brackets here by multiplying the indices together, a to the power of 2w times x to the power of 3w. So let's add the two indices on the right hand side here that are both a, so it's ax squared equals a to the power of k plus 2w. Now you won't mix up the x here because the x is a different base, so you won't mix that up. So therefore on the left and the right hand side, I can tell that on the a's, the power of a is 1, so it's 1 equals k plus 2w. And on the x's, it's going to be 2 equals 3w. So I can tell here that w is equal to 2/3. So w equals 2/3. And then k, I'll need to use this equation up here. So it's going to be 1 equals k, add 4/3, because that's 2 times 2/3, 4/3. Subtract 4/3 on the other side, and you get minus 1/3 equals k. So I've subtracted 4/3 from this line to the next line to get k equals minus 1/3. So there we are, that's the answer for this question here. So what we were doing is we were comparing indices on the right and the left hand side after making up this little equation here, substituting in y where y was needed, substituting in z where z was needed, and then we just worked out comparing the indices. So this step here, this was an important step here. We compared the a indices in this equation here, and we compared the x indices in this equation here to work out w, and then we worked out k afterwards. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so in this question here, I'm going to answer this a slightly different way to just the rules of indices. So what I'm going to do is I'm going to multiply together here 180 of the 2's here by 180 of the 5's here. And when you do 2 times 5, that gives you 10. So it's going to be 10 to the power of 180, and then it would be times 2 cubed, because that's the amount of 2's I've got left, and I've got left no more 5's there. So it's going to be 1 over 10 to the 180 times 1 over 2 cubed. So now this is going to be 10 to the minus 180 times 1 over 8. 182. So what can I do next? It's going to be 1 over 8 is 0.125. So it's going to be x equals 0.125 times 10 to the minus 180. So this is going to be 1.25 times 10 to the minus, so I've made this number here bigger, so I need to make this number here smaller, but it's already a negative number, so to make it even smaller, it's now to the power of minus 181. So therefore, this is a number now in standard form, where it has 180 zeros after it, not 181, because actually if you remember, if you've got something like 2 times 10 to the minus 3, then that's going to be 0.002. So therefore, the amount of zeros after the decimal point is 1 less than the negative number that you've got there. So therefore, I'll write a tiny little explanation here. There are 180 zeros after the decimal point. Okay, so there we are. That's the answer to this question here. A little bit tricky on that one. So we had to use the fact that you can multiply the bases together if you've got the same power. So it's effectively the rule of a times n. So a to the power of n times b to the power of n does equal ab to the power of n. Where you multiply the two numbers together. So a is 2, b is 5. That'll make us a 10. So it's 10 to the 180. And then we rewrote this as an indice. We calculated what 1 over 8 was. We then rewrote it in standard form, because then we can write down how many zeros are going to appear after the decimal point. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so a tricky little question, this one. Let's write n as k squared minus 1. And to start with, we'll factorize it immediately. So we're going to do k plus 1, k minus 1. You can factorize k squared minus 1 like this. Okay, let's now put 2 to the p minus 1 in where k is. So it's going to be 2 to the p minus 1 plus 1, and 2 to the p minus 1 minus another 1. Okay, let's simplify this. On the left-hand bracket, the minus 1 and the plus 1 will cancel, so it's just 2 to the p. On the right-hand bracket, it would be 2 to the p minus 2. Okay, let's factorize out one of these 2's to the front from both of these expressions here. So if I lose one of the 2's from this expression here, I'll gain a 2 at the front, but I'll lose a 2 inside the bracket. So I've moved one of the 2's from the inside the bracket to the outside the bracket, and then I'll factorize the 2 to the front as well. So that will gain a p on the, so I gain a 2 on the front, and it'll be minus 1 inside the bracket. And now we can clearly see it's 2 to the p plus 1 times this value here. So therefore, 2 to the p plus 1 is a factor of n. And there we are, that's the answer for this question here. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question we want to express y in terms of x and a, but they seem to both have t's in them. So we're going to have to get rid of those t's. So what we'll do is we'll take x equals 2a root t and rearrange it to make t the subject. So it's going to be x over 2a, so we divide by the 2a from the right-hand side onto the left-hand side, equals root t. And then we'll square both sides, so that's going to be x over 2a squared equals t. Now what's going to be very helpful here is if we expand the brackets with this square here. So it's going to be x squared over 2 squared is 4, and then a squared is a squared. Okay, so t equals x squared over 4a squared. Now let's start rearranging down this column here. So what I'm now going to do, into y is going to go t equals x squared over 4a squared. So let's go for it. It's going to be y equals a and then it's going to be x squared over 4a squared squared minus 2a bracket x squared over 4a squared. Okay, so let's expand the brackets on all of these. So it's going to be a times by x to the 4 over 16a to the 4 minus 2a times x squared over 4a squared. Okay, also, I don't know why y was being squared there. So it's just y equals. So now what we're going to do is simplify both of these fractions here. What we're going to do is we're going to treat the a here as a over 1 and the 2a here as 2a over 1 and multiply the fractions together. So it's going to be, and now what we can do here is cancel one of the a's out from the top and the bottom. And it's going to be x to the 4 over 16a cubed. And on the second one, we'll cancel out one of the a's on the top and the bottom, so we'll be left with, cancel out the factor of 2 from the top and the bottom as well, x squared over 2a. So there we are. This is what our answer looks like. So it looks like p is equal to 4, q is equal to 2, m is equal to 16, and the last one was n is equal to 2. So there we are, difficult question that one, but here is the answer. So we had to rearrange one formula to get it to equal t equals, to get t the subject, and then substitute t back into this equation up here. Now this strategy here reminds me of the second year of A-level maths, where you have parametric equations and you have to rearrange your parametric equations into Cartesian form. So this is very much a technique for the second year of A-level maths rather than GCSE really. So very well done if you did make some progress on this. Very well done if you've even just understood it really. Okay, and move on to this question here. Pause the video and give this one a go. Right, so final question on the video, this one. Let's make it a good one. So what we'll do is we'll turn all this whole question into twos, and we'll start simplifying now. So we'll add the indices together. So it's going to be 2 to the 5y plus 2 equals 2 cubed to the power of 5y over 2 squared to the power of n. So I've turned all these 8s and 4s into 2s, and there we are. So let's now expand these brackets. Whoops. That's 2 to the 5y plus 2 equals, now we multiply the indices here, 2 to the 15y over 2 to the 2n. Let's now subtract the indices on the right hand side. So it's going to be 2 to the 15y minus 2n. Okay, so now that we've got two indices on the left and the right hand side, we can now set those indices to equal each other. We've got two powers, so we'll set them equal to each other. So 15y minus 2n is equivalent to 5y plus 2. Let's now rearrange this. We want to work out an expression for n in terms of y. So we'll move the n onto the left hand side, and we'll move everything else onto the right hand side. That will be 10y and a minus 2. And we'll divide by 2, so n is equal to 5y minus 1. Okay, so there we are. That's the answer to this question here then. So that's the whole video on indices. So hopefully you found this video helpful. Feel free to go back and use this at some time in the future. Feel free to reuse questions over and over again until you've really understood what's going on here. Lovely. Thanks very much for watching this video, and yeah, hope you found it helpful.